In most developing countries, malnutrition is affecting the growth of infants. But the impact that a poor diet can have on the brain and cognitive development of babies cannot be assessed with the traditional method of measuring the size of their heads. A group of British scientists have travelled to Kaniba, a rural village in Gambia, bringing a sophisticated piece of neuroimaging technology, easily portable and low cost, which allows to investigate the risks of nutritional deficiencies on the brain functions in infants.
In the Gambia, as in much of sub-Saharan Africa, we still have a huge proportion of the population that are stunted. That is, the children are too short for their age, and this is likely due to the early life environment, nutrition, infection, sanitation, and so on. In the Gambia, for example, 25% of children are stunted by the point at which they're by 2 years of age. But what I found particularly intriguing when we looked at the data from the Gambia is that not only were they losing weight and losing length, but they were also dropping down the centiles in terms of head circumference. I became particularly concerned that in episodes of growth faulting or in situations of undernutrition, brain development may not be spared.
Funded by the Bill and Melinda Gates Foundation, the study Bright Brain Imaging for Global Health, a multidisciplinary project by Global FNIRS, has allowed the researchers to obtain the first ever functional brain imaging data of African infants.
Global FNIRS is an initiative that we've set up to introduce a brain imaging technology called functional near-infrared spectroscopy, or FNIRS, into global health projects. The technique of near-infrared spectroscopy relies upon shining light into the brain. So essentially, we're looking inside the brain. We measure the colour of the blood inside the brain, and that tells us how much oxygen it contains. So essentially, we use the light to give us colour maps or oxygen distribution maps of the brain, and this helps us to understand where and how the brain is being activated. So in a normal healthy infant, we would expect certain regions of brain to be activated and oxygen to be diverted to those regions, and that's what we can pick up with this imaging device. We are just embarking on the second phase of our project, which will be studying infants both in Gambia and the UK, and our ambition is to look at developing brain function for age curves.
So this is an example of a curve that you could think of for physical growth. You can imagine that we're going to create these graphs for all of these measures. So we would have a trajectory over time for brain function in a social domain, in an attention domain, in a memory domain, in a functional connectivity domain. So we will be using EEG to try and understand sort of rapid responses in the brain. We will have behavioural markers. We can try and understand their environment more, so we're measuring maternal and paternal health and income, education, caregiving practices, to try and understand the scope of what's happening in brain development, what's affecting it. And this technology is a key part of that, because the NIRS can be used from birth at every single age point. The babies find it very easy to wear. It's just a kind of a swimming cap type thing, so it's not heavy, it's not impeding what they're doing. So they can just wear it while they're watching or playing or listening to things.
The goal of the project is to allow a prompt intervention on babies from an early stage.
We're asking two questions. When, during early development, is nutrition important, and what type of nutrition is important? We're setting up this longitudinal cohort study in the Gambia, following infants from in utero, so recruiting the mothers in pregnancy, and following the infants to 2 years of age. If we're able to understand which components of nutrition are important, we're going to be able to intervene, be that through supplementation programs or policy intervention. If we can understand what processes lead to an impaired development, we can attempt to correct those, which will have an enormous impact in terms of global public health and human capital of the particular populations we're working with.
The results of the study are expected to be published in the next 2 to 3 years. Meanwhile, the FNIRS technique is being disseminated in other developing countries.
We already have systems, as I've said, in use in the Gambia and the UK, but most recently also in Bangladesh. And what we're able to provide is an assessment tool that's cross-cultural, so we can compare between different populations as well as within a population. And this is really I think, very revolutionary in terms of enabling brain imaging to be accessible to these types of populations.